Hey there, I'm Said, and here we would like to introduce a new series to you, and we call it VR from scratch. In this couple of lectures, we would like to go through the VR development in Unreal Engine, and we will use Blueprint and C++ together. In this case, we start our work by creating a new project with a blank template and with the starter content using the C++ structure. It's better to use this instead of going for Blueprint and later create a C++ classes in there because it creates by default the C++ folder and structure for you. The version of Unreal that we are currently using is Unreal Engine 5.1 preview 2. Maybe in the future lectures, if the Unreal is already updated, the Unreal Engine 5.1s, we will also use them. The first things that you will encounter when you open a new project with a blank setting, you will see that it says if you want to use the virtual shadow maps, you need to use shader model 6 and also DirectX 12. Then we will go to the project setting and activate these two settings. The first of all, we will search for shader model 6 or SM6 and activate that. After activation, it asks us to restart the Unreal Engine, but we do not do this because we would like to also change the default RHI to DirectX 12. We will search also for the RHI, or you can go to the Windows to the platforms and Windows setting and then change the RHI there. We will not use the some VR setting like instant stereo yet, but we can test it later in the lecture and to see the performance and other stuff. Also, we are planning to use Lumen and Nanite in this project. For that reason, Lumen should be active and shader model 6 also should be active to be able to use the Lumen. Here, as you can see, we can go to the target RHI and change it to the DirectX 12 as the default setting, and then we can restart the editor. But before that, as we know we will like to develop the VR stuff, we can go to the plugins and activate the OpenXR as API that we will use for our VR. By restarting the Unreal Engine, all of the settings that we need to start our project will be activated and we can proceed. Okay, now our project is open and all of the plugins that we need and also the setting is already active. We can start by creating a new scene to make it easier for us to work with the default setting that we need, like a directional light, exponential height fog, and also simple floor to work with. It's a very good exercise to start by creating a folder with the name of your project, and inside that use a naming convention of the folders. For example, for the maps, I usually use 0, and for Blueprint, the 0.1. To make them organized, and it's also easier later when you have lots of objects or folder to keep them always in order. You can save your scene because later we always open this scene, and also in the editor preferences we change the setting to always open the last open scene, and in project setting we set the maps and mode to the newly created scene. Okay. Also, it's good to add a word setting to the open windows for us on the right hand side. The current layout that you see, it's my personal layout. You can use whatever you want, but I think it would be useful. After adding the word setting, we would like to also have the game mode overrides. For that reason, we will create one blueprint as a game mode base for this VR scene. And it's better maybe to call it game mode VR because it's for our VR maybe experiences, and we can distinguish between this one and non-VR versions if later we want to also make a two version of our game. You can add it as a game mode override, and later you can define your default pawn inside this. The default pawn is a VR character that we will use later. In order to create that default pound, you can either right click here and create a blueprint from the character class, but as I prefer personally to have the main functionality of our character or any object in our scene inside the C++ and then inherit from that, it's better to create a C++ class for that one and then create a blueprint out of that. You can select the default class as a character for the C++ class and just give it a name. It's also better to use the class type as a public to make the folders for you as a public for the C++ header file and private for the C++ file. Let's call this class VR character base. When you press create class, it will take a short while to create this one. Later, when we use the JetBrains Rider, we can also create classes inside the Rider. It's easier from my point of view, and it doesn't need to, you do not need to wait this much to create one class. Also, I'm using the newer version of the Rider. The UI style is a little bit cleaner than before. I like it. It's in early preview access. If you like, you can also test it. It's a Rider 2022.3, I think. One of the other things that I like to have always is a header file and C++ file at the same time side by side, because it makes it easier to switch between them, but also you can use Alt-O to switch between the header file and C++ file later if you like. Also, I move all of the public classes, all of the public methods into the one section, as you can see, to continue working on them in a little bit more structured way. We need to wait just a couple of seconds that the Rider loads everything for us, and after that you can see the color coding is already available. The first thing that we would like to add to our character class is something that is linked to our VR experience, which is camera. We have two types of camera that we can use, but before going into that, we need to create a blueprint from our C++ class that we created. Just right click and inside the all classes, select the VR character base that we created and give it a name. It's also a good exercise to use BP before the name of your blueprints. It makes it easier later to read them. As you can see, the default inheritance from the character class give us some basic components like capsule component, arrow component, and character movement component that will take care of the basic character movement. As you saw, we have two options for the camera, either the default camera or Cine camera. Here, I would like to use the Cine camera for some features, but if you feel it's a little bit computationally expensive for you, you can also use the default camera. We will define a U property for it because we would like to also see this component inside our blueprint, and we will choose the visible anywhere because we would like to see it also in blueprint, but it's not important for the component like this. You can also use edit anywhere. I gave it blueprint read only because it helps us to also get access into the blueprint code structure if we would like to use it later in the blueprint code. And also I gave it a category name. One of the things that if you are using C++, you should care about, if you have some kind of modules that you are using, you should search for them and find the name of the modules on the Unreal documentation. For example, here is a cinematic camera, and add it inside character.build.cs file. After you add this module, then you have access to you can build your project in a proper way. And now we are creating one component as a type of UScene camera component, and we call it VR camera. Inside our C++ code, we create a default subobject for our class and call it VR camera from the type of UScene camera component. We can now attach this VR camera to our root component. The root component of the character class is the capsule component that you saw before inside the blueprint. We can use setup attachment and getting the capsule component to use it. Just remember, you should include the header file for the capsule component as well. And when you attach this, you can now build your class and go back to the Unreal Engine to see the influence of this newly added components to our class. As you can see now, we have the VR camera inside our hierarchy with all of the cinematic camera components options. Okay, but one of the things that I usually recommend is adding another parent object for the VR camera, and we call it VR offset. It gives us some possibility later for managing the position of the camera if we need some modification to it. For example, after teleportation, if we need to fix the camera position, or if we would like to fix the camera position according to the capsule collider later, but we will go through it in the future episode. Don't worry about this right now. Just create using components as a parent for your camera and call it VR offset. In Unreal, all of the components that we are adding, we are using a pointer. Just it's a way that Unreal is handling these things, as we are using U property to be able to see them also in the blueprint. Similar to the VR camera, we create a default sub-object for it from the type of USIN component and give it the same name as the member name, like VR offset here. And this time again we are attaching this scene component to our root component, which is the capsule component, and we can get access to it with the get capsule component. However, we'll change the parent of our VR camera to the VR offset to make the correct hierarchy for our objects. We built the C++ class, and as you can see now we have the VR camera, but it's not in the correct order. In order to fix this, just right click on your blueprint and select reload, and if you open it, and now you can see the order of the objects in the hierarchy, or the order of the components in the hierarchy is now correct. The other points that we will also need to fix is, as you can see, the camera is in the center of our capsule, but as camera height will be calculated on a runtime according to the height of the user or height of the head-mounted display, we need to bring it down to the bottom of the capsule component. There is get method for the half height of this capsule component that we can use it for setting the relative location of our camera by creating the effector and moving in the z-axis with the size of that half capsule height. Now if we build our class, we can see again and that here the camera component, we need to just restart the camera position to see the influenced value. It goes to the top of the capsule. We need to just multiply it by -1 to bring it downward to the 0 position of the capsule. Perfect. That's it. Now we have our camera in the scene and it's already set up. Let's test it in VR. As you can see, now the camera is connected to our character, and if we move our head inside the VR headset, we can see the influence of the movement in the VR. The next things that I would like to add here is the simple movement for our character. In order to do that, first we need some inputs. Here we will use a new input system in the Unreal Engine 5.0, and in Unreal Engine 5.1 is the default setting which called enhanced input system. For this one you need to have input actions first, and I will call it IA as input action and VR move. Later we will also change this name if we need more functionality. And the other things that we need to add is input mapping context. It's very similar to what we did before inside the project setting as an inputs method, as an inputs that we define that which key should do what. But here we have much more functionality. Similar to what you know before for the other things, you can define different keys with different functionality here. And I will select Oculus Touch, for example, trigger axis as an input value for my input action VR move. And also it's important to remember that we are now using axis value. It means it's a float value that updates all the time in a runtime. However, here I selected for the right hand only the trigger, which means it's either it's a 0 or 1. But when you change the input value type from the single value to the float value, then you can also read the value on a runtime with precision. For testing that, you can add a print function into it. The other things that you need to add to your VR character base is in the begin play, you need to get controller and set the values that you saw there to activate the enhanced input method. You can find several tutorials on the YouTube probably. I am not going into the detail of that, but if you need, we can also have a separate lecture only for the enhanced input method. You can also find some good tutorial on the Unreal Engine Unreal Engine YouTube channel for the enhanced input that they talked about the features of it. Okay, the next things that we need to add is a function that should be called after when we want to move the character. It should be from the type of the blueprint callable inside the U function micro to be able to call it inside the blueprint, because I would like to connect it inside the blueprint but write the main functionality in C++. It's the combination that I like to use. However, you can also totally do it in C++ or completely implement everything in the blueprints. Inside the character move forward method, we can first create a vector for the projection of a camera forward vector, because I would like to move towards the camera forward direction. Create a vector of the forward vector of camera in the X and Y direction. We will ignore the camera forward vector in the Z direction. Using this camera forward vector, now we can add it as a word offset to our actor. Here I'm using a very simple method to move our character. Absolutely, we can use other methods and we will discuss about them later in the future episodes or lectures. But this one is very fast to implement and do not need lots of consideration. In that case, we are taking the projected forward vector that we have, the 2D projected of our forward vector, and multiply it with the ratio that is our the value of our input, and multiplying it with something that we can call it maximum speed that we would like to move with that. But we didn't define the maximum speed as a member of or variable inside our class. It's better to define it as a U property that is editable anywhere in our engine or in our editor. And it can be also blueprint read and write, that if we need to modify it in the blueprint later, it should be also possible. I give it a name of category of locomotion, and maybe we can define several type of locomotion values in this category, but I also add a subcategory for this locomotion by adding maybe the move component or movement components name. This value can be a float variable, and the default value, I found the 3 can be a reasonable value at the beginning. It doesn't make you sick easily. Also, you can add a const to that parameter that we made, because we will not change it in our code later. It's just created as a projected of the camera forward vector. Now inside our blueprint, we can connect that method to the input trigger part. And as you can see, we can now easily move with our controller by only pressing the trigger. And it's also can be controlled with the amount of the pressure that we are putting on the trigger button. Okay, let's test it with a little bit more complex scene, just by adding geometry to see whether it will work with, for example, some slope or dropping from somewhere. I'm using also modeling mode in Unreal Engine. It's very handy. You can easily block out the things that you would like to create later. For example, I'm creating a slope here. And the main functionality is by click and drag and then using Control key to do the modeling. After we create that, you can test it again in VR. Just to make sure, check the player collision to be accurate, because it will influence your experience, because your character will also collide with this object. For a fun part, we can also add one stairs at the end to climb above it. Then the other things that we should also consider is getting the safe normal of our projected forward. Otherwise, when we are moving on the slope, our speed will be decreased, because the main value of our forward vector is regarding to the z-axis, but we are removing the z-axis and it will cause a reduction in the speed. But by getting the safe normal, we can have a constant speed in any slope. It depends on the functionality that you will like, but you can easily get it here with this value. The next things that also makes this experience a little bit more fun, and I like myself to always add, and it's maybe one of the reasons that I would like to use the Cine camera instead of the basic camera, is having the dynamic focus on our scene. In order to do that, we create a find focus distance, and then by creating a maximum distance, tracking distance, we can do the line trace each single frame as a tick method to find whether we are tracking or we are tracing one object in our scene in the certain range or not. And if we find the objects that our eyesight can collide with it, we can define the depth of field according to that, or we can define the focus location at that point. In order to do that, we need to first define the start location of our tracing, which is the VR camera, the location, the word location that we can get it by get component location. You can also find the similar methods also in Blueprint. You can either use f vector as a type, or you can type auto, that it automatically finds the the type that you need for it. And we need also the end vector for it, which is the start point, plus a vector from the camera position towards the maximum tracking distance in the direction of forward vector. In this case, we are getting the forward vector and multiplying it with maximum focus tracking distance. As the size of the forward vector is 1, because it's a normalized vector, when you multiply it with the maximum distance, it's taking the distance to the maximum tracking location. The other things that we need is a hit result, because we will save it and we will use it as a location that we would like to do our tracking. Here I change type to the F vector to make it more readable later. And when we have this, now we can check whether we already collide with something by using the if method, by using an if, and inside that we do our line trace. In order to use the line trace, we need to first get the word, and then simply we use line trace single by channel. The arguments that it needs, it's a hit, that a result that we created, then it's need the start location and the end location of the trace. And it also needs the collision channel or collision channel enumerator. And here we can choose visibility channel, because we would like to track against everything that is visible and has collider in our scene. Just to remember, you need to add collider to every object that you would like to have this visibility check for them. One of the things that we can also do, instead of checking whether we are colliding with something or not, and then if it collides, do something, we can check if it's not colliding, totally return and do not do anything else in this method. And if it's not, if it's colliding with something, then we change the focus of our camera. You can easily use a set focus setting, and inside the set focus setting you should define a new focus setting. For that reason, I create a local variable here called focus setting from the type of F camera focus setting. However, it also makes it maybe easier to first define the focus setting for the condition that we do not find any tracing location or any objects that our line trace by channel can hit it, and define the distance to that object. But before that, if it cannot collide with anything, then we can also use the maximum distance to do not have a blurry vision when we cannot find any collider in between. For that reason, I move it before the if, and here I defined the manual focus distance as a maximum focus tracking distance. Okay, I think everything should work here. Let's build it and test whether it will work properly. The other things that we should change to make it more visible, to reduce the f-stop to 0.8. I find this value nice for myself. You can define any other values that you like. Here I will add some simple objects to only see the influence of this focusing distance. I just create a single cylinder and then copy it and move it in another location to see the blurry effect behind each one of them. Let's go to the VR and see them in the action. As you can see here, the focus distance is very far, but when we get close, we have a blurry post-processing effect or depth of field on the background. And I think it's very nice, and Unreal is doing this job very nicely. Also, as we have a collider and gravity for our character, if you go on top of the other objects and just drops down, you totally have the feeling of falling down in VR, which maybe cause some motion sickness. Now it's easy. We already made the simple functionality that we want. We can now use Quixel Megascan asset to create a more interesting result. For example, just search for some kind of stairs with several billions of triangles and just create your scene, and your scene will look awesome. Okay, that's it. We create our basic character with the movement. In the next lecture, we will add a motion controller to our character, and I think it would be very interesting. We will use maybe default templates, hands, but we will modify it, and we have lots of things to do. Looking forward to see you next time. Have a great time with Unreal. Bye.